Hi everyone and welcome back. Hi everyone and welcome back. Welcome to my another stream, and in this stream we are going to cover NestJS with the GraphQL. So I hope you might already aware what is GraphQL and how to work with GraphQL using Node.js. So in this playlist we primarily focus on how to build GraphQL APIs using NestJS. So let's get started. We have a lot to cover in this playlist and we will try to cover as much as possible. Hi everyone, welcome back. Welcome to my another. And this playlist is not like separate playlist. We are already talking about GraphQL. In my previous videos, we covered Apollo GraphQL, we covered Yoga GraphQL with Express. Now it's time to talk about these things with NestJS. So I'm going to add all these videos to the GraphQL master playlist. Okay, I will add that in the description. But like if you are already aware about how GraphQL works, how it works with Express, and you wanted to explore how it is going to work with NestJS, because on my channel I have a lot of content on the NestJS, but all are talking about okay how to build a microservices and all. But what about if I want to build a service which exposes the GraphQL interface instead of REST interface, right? So those things we are going to talk in this playlist. So our focus in this playlist will be on different aspects. First of all, NestJS GraphQL setup, okay, how to actually build the service from the baseline. Then how we can work with the different database like Mongoose with the MongoDB, TypeORM with MySQL, Postgres, and then Prisma with any of the SQL or NoSQL database. That is the main agenda, and we are going to talk about multiple examples. Okay, the main focus is how GraphQL query mutations and subscription can be exposed through NestJS service. Now changing the database, changing the ORM layer is just a simple topic which we can discuss, okay, because the main point is writing queries and mutation. REST, it's all about data. Data can be managed through any ORM ODM layer like Next, SQLize, TypeORM, Prisma, Mongoose, and your database can be SQL or NoSQL. Okay, we are going to build a whole lot of new GraphQL APIs. We will expose them. We will actually play with these queries and mutation through API documentation, right? So that is the overall agenda. If I talk about the multiple sections, then these 5 sections, this whole course is divided. First we will talk about the baseline of NestJS GraphQL. In that also we will talk about multiple options, because NestJS GraphQL module provides some multiple options to manage the typings, manage the schema. It auto generates the schema for us. Okay, so we just need to worry about writing the resolvers, and REST, it generates the schema for us, the typings and all. Section 2 will be, okay, let's focus on Mongoose and let's expose some user APIs or blog post APIs. Now here we are talking about the Mongoose, which is going to talk to MongoDB database, and we will trigger the query and mutation from the console. Section 3, here we will replace Mongoose with the TypeORM or any other ORM ODM layer. Let's say Next is a lightweight query builder, or we can talk about the TypeORM, which is TypeScript heavy, object oriented class based ORM layer, which I have used heavily in my previous videos. Section 4, here we are going to talk about some real world examples like blog app, user authentication, authorization using GraphQL, how to manage the exceptions coming from the service layer to the GraphQL interface, because GraphQL queries and mutations are different from the REST APIs. They both are using the same HTTP protocol to send, get, put, post. In the GraphQL we will talk about only post APIs, HTTP post method. You will be sending query and mutation. So how to deal with the exceptions, the messages which we are receiving, And authentication, authorization, let's say you are using token based authentication, then how we can protect the other APIs when we are using token based authentication in the GraphQL. Another important thing is GraphQL APIs, either you can create them from the scratch, or you can also create some kind of a gateway. I mean, GraphQL service can act as a service which is exposing the GraphQL interface, or that service can act as a middleware which is talking to the multiple REST services and aggregating the data and exposing the data to the client interface. Because I don't wanted to write my all services from scratch in the GraphQL, I have my REST based services, so I can plug this GraphQL NestJS GraphQL middleware on the top, and that act as an API gateway, and my client can access all the APIs through the GraphQL interface. That's the best way of aggregating the data coming from multiple REST based services. And then I also have a thought of covering the Prisma, because we already covered the Prisma ORM. Now in this video we can also talk about, okay, how Prisma ORM will work with the GraphQL NestJS setup. Okay, so there are a lot of things to cover in the whole playlist, so stay tuned. I'm going to post these videos first because this is the old playlist and I wanted to finish this. I have already finished the ORM ODM playlist. This is all about GraphQL master playlist, so I will finish this and then I will move to my full stack clone, which I know that a lot of people are waiting to see the Uber Eats clone coming up. Sorry guys for the delay, but things are things. I'm not getting much time, but whenever I'm getting time, I'm recording my content. Thank you for watching. Hi everyone and welcome back to my playlist, and here we are covering NestJS with GraphQL. Okay, so we have already talked about the introduction and the agenda of this whole playlist. Now we can get started with the writing NestJS application with the GraphQL. So we are going to start everything from the basic, like okay, how to build the basic NestJS application using Nest CLI. So we are going to use NestJS CLI and we are going to build everything from scratch. Okay, like we can generate a simple NestJS project, and then in that project we will introduce all the different things, like okay, how to introduce the GraphQL using NestJS GraphQL modules, and then we will write resolvers and expose query and mutation from the APIs. So I'm starting this project from the scratch so I can explain all the different parts, not some existing boilerplate code which I already have in different repositories. So let's wait for the CLI. Then what we can do is, it's same as the Angular CLI kind of setup. Here we can just do is nest new. This is the next command which we can hit, nest new and the project name. So this is our scaffolding. We are going to use npm. It is installing all the modules, and these are all the folders and the files getting created. Okay, we have nest CLI, we have package.json, we have tsconfig because the code is in TypeScript. We can see one controller, one module and one service, and this is the main module, which is the root module, and the main.ts is bootstrapping that root module. Okay, so it has all the basic structure which we need for the project. Now we can start adding the NestJS GraphQL. In the GraphQL dependencies, we are going to use Postgres, so we can also add the dependencies for the TypeORM, because NestJS TypeORM and NestJS GraphQL, these are the two main modules we are going to use. So we were using NestJS CLI, and with the help of NestJS CLI we were able to create this basic application. This is the basic folder structure which contains the default service, controllers and the modules. Now we need to introduce all the required other modules, because we are now using GraphQL. So there is a NestJS GraphQL module which we have to add to our this module setup. Before going to that direction, one common topic I also wanted to cover is, let's make this folder structure production ready and include all the required things we wanted to have in a project. So what all things we always want to have in any particular JavaScript or TypeScript project. So recently I added one blog, and this blog particularly talks about how to baseline a NestJS microservice. Okay, we call something baseline when it includes all different aspects of a microservice. Let's say here we are writing a GraphQL based service, so it should contain all the test setup, all the linting setup, all the guidelines, all the linting setup, and even you can also introduce some GitHub hooks using Husky, so that whenever you do the commit, it automatically run the prettier, it checks for the linting, and it format your code, right? And it also executes the test cases. You should also have the configurations for the Docker and Docker Compose. You should have the proper compiler configurations and the build configuration with the TS config. CI pipeline, if you are planning to deploy it to Heroku, let's say we are building the GraphQL simple GraphQL app, we can also plan to deploy it to Heroku. So all these things should already be configured. Then we can call a project as a baseline, and the baseline means just after using Nest CLI, we created a barebone folder structure. Now we can add on all the required things. Okay, I need a prettier, I need a ESLint, ESLint RC, prettier RC, I need a GitLab YML file, I need a proc file for the Heroku deployments, or maybe the CI pipeline file based on your deployment. Either you are using GitHub Travis CI or GitLab CI, but your file structure can be something like this. Okay, this is my target. So what do we have in the baseline structure? You should have a ESLint RC if you are using Docker file and Docker Compose dependencies, because we need the Postgres container and the node container, and then just configurations, because we have to write the test cases using just in the NestJS, and all the build configurations for the TS config. Not more if you wanted to start the applications, or you can just use nest CLI start dev command, and all the hooks, the Husky, which is pretty much working with the commit lint, and the prettier to enforce the coding guidelines, right? Commit guidelines, even the commit guidelines when you are randomly putting any commits. So this blog particularly talks about, okay, what all different modules we need. So I will be just adding those in the project and start using them. So let's say I wanted to use a commit lint, so I need to install the commit lint CLI and the commit convention. All these modules I will be adding in the dev dependency of our project. So here these are our dev dependencies. I will put them somewhere in the middle. We already have the, I think, the ESLint configuration, so we don't need to worry about adding them again. Okay, then I think I need to add a config, commit gen config in the package.json. And I think here we are using jest in the package.json only, so we have to remove this jest configuration, and we can have particularly jest e2e config, jest config and all. And I need to write commit lint config.js file in my code base in the root. This will enable the commit lint. Okay, this is the first thing. Now I can introduce Husky in my project. So what I will do is, first of all, I can install, and this should also install other modules which we have recently added. Okay, so what will Husky do? Husky is, I mean, when you are running a scripts automatically, you can actually introduce the GitHub hooks, like when you are doing a commit. Then what you want before commit, you wanted to give a proper format to your commit. Commit can be a feature, can be a bug fix, refactor, build, or the style changes or something like that, right? So before you even create a commit on your GitHub history, local Git history, what it will do, it will run a lint, it will run a prettier, and it will just check all the formatting of the code. So you can introduce the Git hooks. So what you can do is you create a .husky folder, and it will create, and you can introduce the Git hooks. Git hooks can be simple as git commit, git message. So there are pre and post hooks you can introduce for commit, like prepare commit message, pre-commit commit message. So what we will do is we can create one script here, prepare install. So looks like we already have, so we can introduce this script that will do some baselining. So when I do npm run prepare, so basic git hook is installed. This is husky.sh. Now here we will start creating these GitHub hooks, right? So what we are doing is inside Husky we can create this commit message. Okay, then we have a pre-commit, prepare commit message. If you look into the script, it is nothing but it is enforcing some guidelines on us. When we are creating new commit, these pre and post hooks will execute. Okay, let's say the commit message. So these are some of the hooks I'm adding in my project. This is pre-commit and this is my commit message. So now whenever you are adding a new commit, then this pre-commit hook will introduce and it will run the lint and it will run the prettier, and it is just using the Husky to do all those things. Okay, now with Husky we can also think about introducing the prettier, because Husky is enforcing prettier to execute. So let's talk about that first, setting up the ESLint and prettier. So for the ESLint, like now TSLint will be deprecated soon, we will be using ESLint everywhere only. So these are some of the modules. I think these are already there. If we look into my package.json, all the ESLint related dev dependencies. So these are starting from here to here. So do we have everything already there? The parser, ESLint plugin, and config parser and the config prettier. If you wanted to add on other plugins, you can add, but looks like I do have everything required. Now I can create my ESLint RC. I think we already have some default one. Now it depends on, okay, what do you want? This ESLint RC is using extending these plugins, the recommended ESLint standards and the prettier standards. So I think this is already satisfying our needs, that we are using recommended, and we are also introducing the prettier formatting. So prettier will override whatever the rules which has been imported from the TSLint standard. Okay, this is also doing the same thing. We are using recommended and ESLint recommended, and we are also using the prettier recommended. Okay, now prettier RC, this is the file which we can introduce. These are the common prettier configurations. We can add some more. These rules will override some rules, some standard rules provided by the ESLint, and then we can write these standard npm scripts. What these are doing: npm run lint, npm run prettier, npm run prettier write, npm run format, npm run lint fix. These are something which we will need while writing the code every time, like prettier write, prettier format, and all these things. I think some of these we might already have, like the format. So what we will do is we will put our stuff, and this looks nice now, and we can execute npm run prettier. What it will do is it will run prettier against all the JS files, TypeScript files, YAML and all. Prettier write, you are giving a right to the prettier to update the files if there is a formatting mismatch, right? And then there is a format. So these are all the commands which we are using. And then build configurations. It's good to have a one common build configuration, but what we can do is we can have a two build configuration which is already there in the Nest CLI. This tsconfig build is extending the global tsconfig, and sometimes you wanted to override the tsconfig parameters just for creating the build. Then you can actually override them. So this is my main tsconfig. What it is saying is, okay, modules I'm using common.js, my out directory is dist, target is ES 2017, all the TypeScript compiler options, metadata decorators, experimental decorators, and all these flags, strict nulls, and all. Now, if I wanted to override few properties, I can do it. So what I'm doing is you can extend the tsconfig and create the build config. And here I can provide my additional compiler option. So let's keep it dist only. Okay, root directory is / declaration false, remove comment. So this is particularly I'm creating for build, right? I don't need source map and all these things, and I wanted to exclude all the things which I don't want to be executed in the build. So there may be a coverage, there may be some other folders. You can exclude all the type of folders which you don't want to put inside a build. So I don't want it to build node modules, all the tests, everything which is there in the dist. I don't want it to build it because that is the outcome, and tests I'm skipping, right? And then all the test related configurations. Test related configuration means we are using jest, and in this baseline project which is generated from the Nest CLI, here I think the jest configurations has been placed in the package.json itself. What we can do is we can remove or isolate these things. Let me just clean up the package.json. Here we have the jest configuration, but what happens is when we are writing the NestJS, we always have the jest config, then we have just e2e config, and a lot of other jest related configurations. So it's better that we should create our own configuration files for the jest. And we already have, I think, the commands to run the tests. Test is using jest, test watch, test coverage, right? So what we can do, we can create a simple jest config file, jestconfig.ts, and that will take care of all these things. And one more file which you can add is just e2e. I think it should look like just e2e.config.js, and with some modifications from the existing jest configuration you should be able to add. Okay, so let's take a look onto these things. We have, I think we need to check the jest config. It's just config.e2e. Like if you wanted to write end-to-end test cases, you want to have something else, then you can have this separate configuration. And what does it has? It has the same things, but if you want to execute the test, because here we are targeting a particular set of files, right, which contains the e2e.js, e2e.spec.js. So I will just test config e2e, and then we have a just config. Just config. If we read this configuration file, it is plain and simple. What it is doing is set up files. Here these are the setup files before running the test cases. What it is saying is inside test I need setup environment variable file. So inside test I will create one file which will help us to bootstrap the environments for the test projects. And what we are doing inside this, we are just writing these 2 lines of code. What we are saying is use the .env and put everything inside process.env from env.test. So we need to create env.test file that will be used for test environment, and .env will be used for local environment, and this we are not going to commit. We are going to create env.example file. so you can take a look what all environment variables we are going to populate. Okay, so looks like we have most of the setup ready. Now we can introduce the Docker, which is the last thing I think we have, and that is also important one. So most of the projects which I am building are either using Postgres, some kind of a ORM tool with some database, MySQL, Postgres or MongoDB. So it's two container project. One is a Node.js container, another is a Postgres. So we can create a Docker file. Sometimes, I mean, your baseline project should contains all the configuration. It doesn't mean that you wanted to use all the containers. You can disable, enable or comment the container you wanted to use. Here we are using TypeORM. So we also need to create orm config.ts. If you are using TypeORM, then you are already aware. We are not going to put anything inside this, but later we will put something there. Okay, then we have ts config. Now let's create a Docker file. Docker file is same as like other Docker files. What we are doing here is we are just spinning up the node container and copying the code, copying the package and package log file, and just doing npm run build and exposing the port. This is from all my baseline projects we have. And finally we are executing this command npm run start prod. Okay, and this is Buster Slim image, which is a lightweight image, and we are using this Docker entry point. This script is just to, okay, when you are starting the Docker again and again, we don't need to execute npm install and all these things or TypeORM migrations. So these are some custom script I have added as a Docker entry point, which will get executed and it will save our time when we are spinning up container again and again. And then we have Docker compose file. I always create Docker compose and Docker compose override. The Docker compose contains your containers, what all containers you want to have, and I think we should have something already placed in this. So what do I have? I have two containers. One is the node container, another is a Postgres. Right, node container is being built from this current folder. There is a Docker file. I think we can skip the volume for the npmrc, and it is pointing like this. This is the volume mapping of the current source code in the root directory with the app inside the container, and we are using Postgres. Another is I'm using Docker compose override. Here I will expose the ports and all the environment variables. Okay, I misplaced the code. It should be Docker compose override, and this should be inside Docker compose YML. You may not need a Node.js container. What I do is once your application is up and running, you can actually start using Node even without container. You can just do npm run start dev, and for Postgres, like if you are using database connection, you can use just localhost and the port name. The port name for the database is 5434 for your host system. Okay, and these are the environment variables I have. So this is a plain and simple Docker setup. We will spin up the containers and we will see how it is going to work. Okay, so if we look into Docker compose override file, here we are using Docker utils. We are mounting Docker utils into entry point for the Docker. So what this Docker utils will do, we can have some custom script which will bootstrap our Postgres container with the predefined set of database. So what we are doing is we are passing this variable, right? Example API testing. So what we want is when the container is coming up, we already have these two database and our application starts connecting and using these database. So we can create this Docker util folders. So this is the, I think the last thing we have, and after that we will test our application. So create new folder, and we have Docker utils, and inside Docker utils we are going to put some script. Hi everyone, welcome back. Welcome to my another brand new playlist. Hi everyone, welcome back. Welcome to my another brand new playlist. And this playlist, so this is our validates your variables like env should and domain module I will import in the app.module. Okay, this is a single folder structure. I will put all the controllers of this whole project here, DTOs, entities, pro API, .yml, that I will check later that what all things we can have inside this, right? Or you can have some another configuration based on your CI tool like Circle CI, Travis CI, or GitLab CI, and npm rc file if you are using some external private module, or your organization has a GitLab registry or some private npm registry from where you wanted to fetch the modules. In that case, you can have npm rc. Rest we have a env.test, env.example configurations. If you wanted to use nodemon, this is my favorite module. Like whenever I change the code, I wanted to restart the application, but that is also provided by NestCLI. I think that is start dev. It actually watch all your changes happening in your src and it will keep restarting your application. So nodemon is not required. You can have a new relic if you are using some application performance monitoring tool. Just write a nice and clean readme file, and this is your the basic project. Now we will run the docker containers and we will see the application running. Okay, so let's start our application. What we can do is first we can check our docker container. It is running. Okay, we can just do docker compose down. We'll kill this container and we will create this container again, and we can also check if any of the volume has been created by this. Okay, so docker compose up. So because we are also going to use this Postgres database script, which should create a database for us. Let's see how it goes, and then we will start our application. I think we got some permission issues. Okay, it has created database and it has interrupted here, permission denied. So let's do chmod docker utils and then try this again. Maybe we need to kill this docker volume if it has been created. Even kill the container. Just for cleanup, and then do the docker compose up again. Okay, now you can see the statements. It is creating the role, creating the database, and we are good. This container is up and running. We will use this database once we have the GraphQL APIs running and they start consuming using TypeORM. Okay, for now we can just see our application. We can do npm install again. because we have added some packages directly in the package.json, so it's better we do npm install again. That will install all the required dependencies which we have added additionally, and then we can do npm run start. That will just start the application where we don't have much right now. It's just going to bootstrap on 3000 port. Later we'll introduce all the configurations like populating something in the env, like something like connection url, host, port, and all the runtime configurations which we need for TypeORM for the GraphQL modules. Okay, now to introduce GraphQL in our project, what do we need? So currently we have basic bare bone structure with the project baseline. Now we will start adding things onto this project. Okay, when I say some things, that means NestJS GraphQL module, because that will enable our NestJS microservice to expose the GraphQL interface. Then we will write mutations and the resolvers. Those are nothing but the ES6 classes, TypeScript classes, and we will write some modules. So inside src we can create modules, and inside modules we can create all the modules which we want, either it is a domain or a module. So we can create API module. Sometimes it is little slow. Okay, and we can do npm run start dev. That will keep starting my application. So instead of modules I will call it as a domain, and inside domain we can create all the entities. Let's say inside domain we can have, there are two type of folder strategies we can use in the NestJS enterprise project. Either you can call it as a modules, okay, the user module, account module, feature module, and every module will contain their entities, controllers, DTOs, services, factories, providers inside that folder. Let's say if I'm creating a user or auth, right? Now inside user I will create all the DTO, let's say DTO, and then I will create services and controllers, providers, same as it is like. But currently we are not creating a big application, so what we can do, I can use a aggregated folder structure strategy where I have entities which will contain all the entities, services contains all the services. What we can do is, let me just delete this one. I will create domain again, or we cannot call it as a domain. Let's put a modules, and here I can create, okay, there is a config module, okay, and we are going to have a database module. One you can call shared module. These are the modules, and these are actually, you can call external module, like database module will be used by all the modules, config module will be used by all the modules, and shared modules. And then you can also add a feature modules. Feature modules is like, okay, API module. Currently we have only one API module. API can be a user APIs, account APIs, or something like that. Okay, here we will put all the entities. Now this API module, here we can put entity, all our services, all our controllers, providers. So this will become a root module, and these are the additional modules. To make it, I'm always confused with the names. Domain, and in this domain I have all the modules. I can call it as a DTO, services, controllers, providers, all these things I'm going to have. And these are the external module, like config module, database module, shared module, and you will expose the domain module from here, and domain module I will import in the app.module. Okay, this is a single folder structure. I will put all the controllers of this whole project here, DTOs, entities, providers and services. Okay, let's see now in the next part like how we are going to introduce NestJS GraphQL. I mean, that is fairly easy. What we can do is we can start adding that as a dependency in our project. Currently it is just a bare bone structure, so our node application is started, but let's add our additional modules. Npm install -- save. These are the core modules. So what we are going to use is NestJS GraphQL. Okay, NestJS TypeORM, I think I already have added. That is nothing to do with the GraphQL. NestJS GraphQL we have, and type GraphQL for some typing support, TypeORM for NestJS TypeORM, and I will use GraphQL is another module, and GraphQL tools. I think I'm writing this correctly. GraphQL tools, and Apollo Server Express. I mean, this is all built on the Apollo Express server. I mean, this NestJS also built on top of Express, and NestJS GraphQL is just implementation on top of that. So it is hiding the overlying implementation and providing the annotations and all to create your resolvers and the queries. Okay, and then I will install some dev dependencies respective to all these modules, and we are good to start. Okay, so we have all the required modules: NestJS TypeORM, NestJS GraphQL, and GraphQL Apollo Server Express, GraphQL tools. Looks like we have everything, and now we can start using all these modules in our app module. Let's see how we are going to bootstrap the app module. Or we can just create one domain module. Because this is going to be the second root module. So we have app module will be dependent on the domain module. So this will be everything. So instead of providing everything inside app module, I will use the domain module for all these things. Currently I don't have a controllers and services. Soon I will have these, and I will introduce them. Okay, so in the imports I need to specify what all modules I am importing. So as I talked about, we are going to use config module. Config module is something which is provided by NestJS config. Okay, so what we need to do is config module dot, I think I need to import this. Config module dot for root is a method, and you can actually pass all the configurations. Config module dot for root, the default implementation will look into your .env file and put all those environment variables in the process.env. Okay, we need to have a NestJS config. I think I already have it. Import config module from NestJS config. Okay, I was not having it. And then it is providing the validation schema also. With the help of that, you can actually validate your environment variables. So that is important thing. Validate schema.joy object. And regarding that, I also covered one article on my blogs, like what all possible ways you can actually populate the environment variables for your NestJS project. So managing environment in all different ways for your NestJS project. Let's say because either you will be using NestJS config module or you will be writing your own config module. It's all same, right? Here what I'm doing is config module.for root, and I'm saying explicitly, okay, I'm just passing you this env file path, which can be dev env, production env. Just use that. Okay, and if you are using the default implementation, then it will just look for whatever is in the .env and put that in the process.env. Okay, or you can specify the environment file path. Or the other option is, with the help of config module, you can also do the validation schema. What it does is it actually validates your variables, like env should be a string, port should be a number, or db URL should be a string. All the environment variables either can be a boolean, number, or a string. You can also do a validate. Right, node environment variable, node env name can be develop, production, staging, QA, nothing else. The default will be development if you are not specifying. All these things you can specify, and you can also write your own config service, something like this. Okay, here I wrote my config service and my own config modules, and providing a mechanism to load all the config variables in the process.env. And when I want to use it, I'm using it something like this, config module, like this, config service .get.db, because I might have created a getter method in the config service. Okay, you can check out this. There are many possible ways of doing it. We are just using one of it. So here we can specify all the validation criteria. Okay, so we are using validation schema to validate the environment variables, and we are using Joy. So let's install that module first, and then we will import it. And here we can import this Joy in our project, so we can validate all the environment variables which we are using. I copied from NestJS documentation, and here in the validation schema, what all things we have, we can use, okay, node environment variables should be of type this, port should be of type this or that, so that I will be passing here. So another required variables we have is the database URL. We already know that we are using Postgres, so for TypeORM the connection type will be Postgres, and here it will be joy.string, and it will be required. Okay, so these are the validation schema I have. What does this mean is all these modules are required, and we have to pass them. Okay, this is all about the config module. Now config modules, we have a node environment, port, and the database URL. These are the minimum basic things we need. Now we can also import the TypeORM module, because the TypeORM module we are going to use everywhere in our project. So NestJS TypeORM, because that is our database layer, TypeORM module, and here we are going to dynamically initialize it using TypeORM module dot, let's see how we do it, TypeORM module dot for root async. There are different methods TypeORM module provide, for root async. So here you can see for root async, this is a synchronous dynamic initialization of a NestJS project. And here we can provide the dependency, because what it needs is we need to feed a configurations here. So we will be passing config module, and we will be injecting the config service, inject config service, and inside use factory, because these are the three arguments, use factory, use class. So we will be adding the config service. We will be passing the config service, of type config service, and we are going to return the config module options for this module. Okay, config service, we need to import it from NestJS config, and what we need to return, we can return the whole NestJS TypeORM config module options. So if we see TypeORM module options, which are name, okay, if I go inside this connection options, these are all our connection options. I think it should be extending TypeORM module options. I mean, the connection options is the object which we need to pass to initialize this module. Okay, let's see this. So what all things we needed? We needed the name of the connection, which is, let's say, default, and I will pass type. Type is Postgres, because we need to tell TypeORM, okay, my database is Postgres, and then I can simply use URL. And how you will get URL? We can use config service dot get and the same variable database URL, and all the other things also you can pass which are required. Entities, inside entities you will be passing all the ORM entities which you have. Either you will be passing some directory name, okay, this is the particular directory where I have all the ORM entities created for TypeORM, and then synchronize, which I always keep false even for local development. Okay, so this is our TypeORM config module. Now next thing is we will be using NestJS GraphQL module, and these ORM options are TypeORM async module options. Okay, now next module we are going to use is GraphQL module.for root, because this is a GraphQL project. Okay, and just import this GraphQL module. Now what all things we can pass to initialize this module, right? So there are a couple of options like playground, your all the definitions where you are passing. Playground is true. And definitions means you have to provide a path where the schemas are kept. Okay, so we will talk about all these options, like how we are going to provide a definitions and what is the type path and what is the playground. Currently I'm passing all these things, but in the next video we will talk about, okay, what all different options you can provide. Either you already have a GraphQL schema you can pass, or you can generate the GraphQL schema from the resolvers and the queries you have already written. Okay, so let's see all these options in the next video, where we will try to understand how NestJS GraphQL module initialization really works. Okay, because at the end what we need is type definitions, resolvers and queries, and this is a simple implementation of a Yoga GraphQL or Apollo GraphQL server. It's built on top of the same thing. It's just like we need to write less code, and we just need to use annotations to do everything. Okay, let's catch up in the next video. Meanwhile, you can take a look onto this. I will also push this code to the GitHub. Hi everyone and welcome back. So this is the part 2 of our setup which we are doing for NestJS GraphQL. So in the first video we did all the folder structuring, we did all creating all the different kind of files, like for jest, for testing, for Docker, for creating the Postgres containers. Then we set up the hooks using GitHub hooks, using Husky. We set up prettier and all the configuration part. Now we have started writing the actual code. So here we have created a domain module. In the domain module we are using config module, TypeORM module and the GraphQL module. Okay, What we will do is we will start writing the modules. Let's say we are creating a Pokemon app here. Okay, so what we will do is first we will configure the GraphQL module. So if you look into GraphQL module.for root, it is taking all these arguments. We might also need to pass some more argument that we will see. So this is our domain module. Now this domain module can be imported in the app module. I think I have already added this domain module, and now as we already have this container running, docker compose up, I can just do npm run start dev. And let's see, we are doing the live debugging. So if there is any error, we will try to debug this and we will fix that. First thing I see is whenever you are using NestJS GraphQL module, I think you need to pass the driver. That driver can be Apollo driver or any other driver which we are using. Apollo driver is coming from the NestJS Apollo, and we can also use, I think, the other drivers which are specified here. Mercurius, that is also we have to use Mercurius driver or Mercurius driver config. So let's see, we are running the application and let's see how much it is able to pass. We also need to fix all these different paths, like where is the entity. For the TypeORM, where are we keeping all the entity files, and for GraphQL modules, the type paths are correct or not. And this is the definition it is going to generate by looking at your GraphQL type definitions. It will generate this schema. Okay, let's see, I think it is throwing some error. Yes, error, missing driver option in the latest version. I think earlier version driver was not mandatory, but now to allow the integration with the different drivers, you have to pass the Apollo driver, because here you can also pass the Apollo driver config. The for root method is Apollo driver config. Okay, and for that I think we have to install some module which we can do. So npm install --save NestJS Apollo. I think this is the module NestJS Apollo, and we can get Apollo driver from there. So we need two different things, Apollo driver and the driver config. And we can pass the driver to the GraphQL module. There is option driver, that can be Apollo driver. Now if you look into the for root method, what all option it accepts. So if I mouse over, for root method implementation, if we look into the types, so it is extending the GraphQL module options. Inside GraphQL module options, you can see path, type definitions, type, path, and driver. This driver you can either pass Apollo driver or the Mercurius driver, and all the playground you can also pass the schema, the resolvers, all these options. I mean, we just need to take care about the required parameters while calling this for root method. Now it is again breaking. Okay, we forgot to install because we are using Postgres module and we didn't even install it. So obviously it's not good, it will break. So we will install this another module which is PZ Postgres. So if we are using TypeORM with the MySQL, then you have to install MySQL. TypeORM with the Postgres, then you need to install the PZ. PZ is a module. Okay, it will again throw an error. So let's go back to our domain module. Now let's see the difference here. This is the documentation. So if you are looking for Mercurius integration, then you should be using Mercurius driver and Mercurius driver config. Similarly, there is a Mercurius driver config here, and here we are using Apollo driver which is coming from NestJS Apollo. Okay, you can also pass the playground true or false. Based on that, it will expose the playground on the GraphQL route. Okay, so let's see the other things. Okay, I think this is installed. This is still taking time. Okay, so now we have Postgres pgadmin already installed. Now what we can do is npm run start dev, and these are our environment variables, node env, port, and database url, and this is our domain module. And currently we don't have any paths defined, right? These are the type path where you create a .graphql files in your different folders where you are creating your resolvers and queries. Currently it's every folder is empty. So let's see how it is going to react with that, because I think it will not be able to initialize the GraphQL module if you don't have any type already created in any particular path, at least one type definition already created. Okay, so let's see how we do it. Now what we are going to do is, let's say we are going to create some Pokemon GraphQL APIs where you can see the list, of Pokemons, get the Pokemon by ID, create a Pokemon, and all these things. And here we see the error, and the error is no type definition were found in this pattern. Okay, because we haven't created one. What we are going to do now is, let's create something. So inside domains folder, I think we have domain module here. What I will do is I will remove these folders. You can still keep the entity, and we are going to create the APIs here. Like in the domain, I can create one is Pokemon folder. This is the Pokemon domain, and another folder I have the league. Okay, and then we will start defining all those things inside this. Now let's say inside Pokemon, if I create the GraphQL file, then my path should be something like this. Go inside all the folders and look for .graphql file. Okay, so this syntax will work, the type path definition will work. Here what we need to do, we need to create the GraphQL files. Now because we are writing GraphQL, NestJS GraphQL, but still the concepts are same, you need to create a type GraphQL file where you define your queries and your mutations and your schema types. Okay, so we are going to the domains and Pokemon. So I will start creating the files here. Pokemon.module.ts. Then other important files, I will create all of these. Pokemon.graphql, GraphQL file, and what other files we need? We need one service and we need one resolver. Pokemon.service.ts, and then one is resolver file. Here we will define all the queries and mutation, and service will deal with the database, getting things and all. Now this GraphQL file is important, and here we are going to define all our types. Okay, what all types we are using, all the types we'll put here. So these are all our GraphQL types, and we are going to use the same syntax. Type Pokemon, and here it can contains ID as a string, and this is required, and then name as a string, type name, ID name type. And we also have a league for each and every Pokemon. So we are going to assign the type league. This is another type which we have to create. And now we will define all the queries. So in query, you see we are going to get all the Pokemons, it is going to return the array of Pokemon. And another thing is get Pokemon by ID. So another thing is Pokemons, it is going to receive ID of type ID, I guess, and it is going to return a single Pokemon object. Okay, so this is inside our query. I think I need to install some GraphQL plugins so it can beautify this automatically. And we have type mutation, and inside type mutation you will define all your methods. Like, okay, let's say I have a create method. Create method is taking some argument, like there is a name string, type string. Okay, these are two arguments, let's say it is taking, and it is going to return the newly created Pokemon. Then we have update, like CRUD operation you can think of, create update, and what you will do is you will pass the ID of type ID, and you will pass name is of type string, and then this is also required, type is also of type string. This S is capital in the string when you are defining the GraphQL type definitions. Okay, so we have type and mutation, and then there is a delete. Delete is taking ID only, and it is going to return, like it can also return another type, deleted. Deleted is a custom type, right? So you have to define the deleted type, which contains only one parameter. Delete is boolean. It will tell you, okay, deleted true or false. Okay, so there is a Pokemon. I think this is just a typo. Okay, so we have defined the GraphQL. I think now if I try to restart this, let's see, because the league type is not defined. Okay, that is fine. So we will try to run this when we have all the type definitions ready. So this is the Pokemon.GraphQL. Now we just need to create a module, resolvers and service, and inside resolvers we will be using all these methods like create, update, delete, and the resolver will talk to the injectable service that will be dealing with the TypeORM repositories to fetch, delete, update, all these different kind of operations. Okay, so now let's create the entities. So we have two entities here. One is a Pokemon, another is a league. And there will be one-to-many relationship. One Pokemon can be a part of multiple leagues. So we'll create entities, and what we will do is, because these are TypeORM entities, and using repository pattern inside the services, we should be able to access these tables, the Pokemon and the league. So there are two entities we are creating. One is the Pokemon dot entity dot ts, another is the league dot entity dot ts. Okay, and these will be representing two different tables, and what you will do is, after you have written the entities, you can enable the TypeORM synchronize true, so automatically these will be populated in the database. Let's say if I do synchronize true, and you already know the power of this. Synchronize true means it keeps synchronizing these things with the entities. So we have Pokemon entity. So Pokemon entity is simple. What it has is it has a name, type, and one-to-many relationship. Okay, league.pokemon, and then there is a league entity. League entity is like having many-to-one relationship with the Pokemon. I'm just copying this from my template. This is the UUID. Then we have a league name, and the league name has a relationship many to one. So Pokemon has a one to many. So inside Pokemon is can have many to one. So this is the relationship Pokemon entity is having. So whatever the type, so this league will represent a single league for the Pokemon, but a single league can be assigned to the multiple Pokemons, so it's one to many, and this is many to one. Okay, if I do npm run db sync, I can do that manually also. Okay, let's see, it is a type error. So we go to GraphQL, and what it is saying is there is a type deleted, syntax expected column found name delete. Okay, because currently my project is not complete, so I don't know like from where this error is coming. Okay, we'll figure this out. So here we have a Pokemon module, Pokemon resolver and service. Now after creating this entity, are we pointing to this entity correctly? So there is a domain module. From domain module, what we are looking into is the folder, and inside the folder all the files having .entity.ts. Okay, so that is good. Okay, this is configured properly, we don't have any problem. Synchronize true, so whenever TypeORM module is getting bootstrapped, it will check, it will synchronize these tables. If these tables are not there, then it will create both the tables in the database. Okay, after the entities are there, we can start creating the Pokemon resolver and Pokemon service. So what I mean is we have to create a Pokemon service which will actually use this repository, Pokemon repository, and will do the basic operation dot find by ID, update, create, all these. Similarly, we will define all the methods, Pokemon service. The important part in this is how we define the resolvers, because there we are going to use custom annotations, annotation mutation, annotation query, because we have already seen a lot of examples of CRUD operations. Even the different examples I already covered, where we are writing controllers, services, and helper service. Here we don't have a controllers, here we have the modules, resolvers, and our service. And this is the type definitions. Okay, I'm going to have these three different methods exposed in the resolver, and I think two queries, get all Pokemons, get Pokemon by ID, and three different methods, create, update, and delete. Okay, so we can define the other methods here, which is like, okay, async show, which will talk about showing all the Pokemons, and we can use these methods, async show, async get show by ID. So we'll take ID string, async get all Pokemons, and there is update Pokemon also based on some ID and data. So this is our service. I mean, I'm just writing it quickly, ID, and there can be a data of type any. While create also, I mean, it will not be any, it will be representing some DTO, delete Pokemon show. And now let's start writing these methods. Okay, here we can return whatever is in the table, return await this dot, what is the repository name, Pokemon repository. Let's make it a little small. Pokemon repository. dot find, give me all the Pokemons, and here find by ID. Here we are doing find one. I mean, all these are TypeORM methods, and here we are doing where close ID is this. Okay, and inside update Pokemon, first we will do the find one. So we will get the Pokemon based on the ID first. If we got the Pokemon, then we'll update it. What we need to do is Pokemon dot, let's say, the name, which we are getting data from data dot name, data dot type. Data dot type. Once we update all the parameters, we can simply say await Pokemon dot save, so it will save the updated version, and you can also return whatever is the Pokemon you have updated. So that is update. Similarly, we can have a delete. Delete will be simply all like this. I think there is a destroy, but a destroy option. What we can do is first we will find one, because we also want to return the which Pokemon we have deleted. So we can say this dot Pokemon repository dot delete by ID, I think, and we can pass the ID. And once this is done, we can return the deleted record, and we are not checking if this particular record exists or not. Those are all those things are for error handling cases. What if the record doesn't exist? Then you should throw an exception from here that should be handled at the resolver level. Okay, so here const Pokemon, or let's say we can use this dot Pokemon repository dot create empty object, and then set all these parameters. So we created a Pokemon object. We set the name and data type from the data, and then const saved Pokemon and return that. All these things we are doing. We have create, update, delete, and show, get all Pokemons, the basic methods. Okay, now the important part is the resolver, like how we are going to map these service methods with the resolver. We have defined the type definition, the .graphql file, where we have specified, okay, this is the Pokemon kind of model, and we are specifying two query methods: get Pokemon by ID, get all Pokemon, and there are three mutations: create, update, delete. So how the resolver will look like? Resolver is a GraphQL, NestJS implementation for doing the same thing, which we are doing by creating a simple class and defining all the resolvers, defining all the mutations and the queries. So we are doing it in the same way. We will just create a class, and we'll use all sort of annotations, and it will be an injectable class. Pokemon resolver, and inside a constructor you will provide the service injection, private read only. This is Pokemon service. Okay, so we have done the constructor injection. Now we can start using something like this query. Here I will write the method, okay, async Pokemons. So here this is the query. I will import this query where it is coming from. it should be coming from type GraphQL or NestJS GraphQL and Pokemon. So what I can do is this dot, we have this method, so return await this dot Pokemon service, same as like in from the controller we used to call service. Now from resolver we are calling the service methods, get all Pokemons, that's it. So similarly there is another query which is taking ID as an argument, right? So only the difference will be, okay, here we are going to pass all the argument and the argument is the Pokemon ID, right? So this is how you pass the argument and the argument is the ID. ID is of type string. Do I need to import something? So I need to import argument because argument is the input. It's args. I will be getting this from NestJS GraphQL. Let's see what is there now. Okay, sorry. This should not come here. This should be the part of the method get and I can call the appropriate method, that is, okay, get all Pokemon. What is the other method we have? Show method, and it is taking ID. It's better that we should just write get Pokemon. This method is nice, and here we are going to call this, we'll pass the ID. Okay, so the query methods are done. Now what we need to do, we need to talk about the resolvers. I mean the mutation resolvers. Mutation means you are doing create, update and delete. So this is simple. Now instead of query you will start adding the mutation. You will start adding the mutation and delete, and we'll just import all the required things. NestJS GraphQL, and what method do we have there? Delete Pokemon. Okay, similarly we have the mutation create where we are taking all the arguments like the whole payload body and all, name, type. These are the two inputs we are taking. This is the mutation and we are calling the create Pokemon with both these arguments. And similarly you can write update, delete and all. Now another important part is the resolver annotation here, and it's a resolver for which particular entity, and that entity you have to specify. This is Pokemon entity. Okay, just fix the imports. Pokemon entity we can get it from the entities, and we are done. So this is the resolver. Now when you import all the resolvers and the services in the main module, all these things will get resolved. So here is our Pokemon module, it's empty. Here we are using TypeORM module.4 feature, Pokemon entity, because we are accessing Pokemon entity, and these are the providers. We can also export them if it is needed. Okay, this is our Pokemon module. Okay, where it is the Pokemon entity. Let's import these things. And this resolver is defined. We are done. So this is the Pokemon module. Pokemon module is taking these two services, Pokemon service and resolver. We don't have a controller because controller is for REST API router. Here we are writing GraphQL APIs. This is the type definitions, queries, mutations and all. Similarly, same thing you will do on the league. Here you will create .graphql, okay, and you will define the types, and inside type you will specify, okay, this is my type league, which I'm using in the Pokemon also, and here I will specify type query, I will specify type mutation, and inside I will just define our create league, update league, delete league. These are the three methods I have inside mutations, which are actually updating the resources. And when it comes to fetching the resources, I can fetch all the leagues or a single league by ID. So my type definition is simple. Now similarly, I will create a resolver and a service, right? This is same as like the Pokemon resolver and Pokemon service. The whole agenda is to understand the whole flow, how it is really working, and then I will just update this league module with league resolver and league service, and then we will see the whole demo together, that how all these pieces are combining and bootstrapping our GraphQL server, where we can actually create the Pokemon, fetch all the Pokemons, fetch Pokemon by ID, and create a league, assign the league to a Pokemon, all these kind of operations. Okay, so we have already created league.graphql. These are like the type definitions. We have type league, and these are the queries, and these are the mutations. And respective to the league, I have created a service and the resolver. I mean, that service is simple, which is just doing a CRUD operations, create league, get all the leagues, or update a particular league or delete a league. The same kind of operations which we have done in the Pokemon service, where we are actually creating Pokemon, deleting, updating, and getting all the Pokemon and getting a Pokemon by ID. So how we are doing it? So there are three important things. First of all, you have to define the .graphql file, define all your types, queries, and mutations. And you can also create a custom type like this. Here what I'm saying through this query is, give me Pokemons. So it is going to give you the array of all the Pokemons, and that is going to have these attributes. Pokemon by ID, it is going to give us a single object. And when you do the create, update, delete, create update should return the Pokemon object, and delete should return the Boolean delete, which is true or false. Similarly, the league.graphql, here we have the league as a type, and we have two things, query, mutations. You can also have a subscriptions. Here inside a query, league, give me all the leagues, league by ID, create league should return a league, update league, so create league should take a input name and return a newly created league, update league based on the ID, and I'm passing the name, delete league, I'm deleting the Pokemon league, that's it. And after this .graphql file, the another important thing is the service and the resolver. First, resolver. In the resolver, we are defining the annotations like query, mutations, and automatically these are getting mapped to the GraphQL definition query. It is not taking any argument, and what it is doing is, okay, give me all the leagues. Here there is another query where we are taking the argument ID as an input and returning the league by ID. Here the mutation, delete league, update league, create league. So if you look into this method, create league, update league, delete league, all are getting mapped to the resolvers, right? So we have leagues, and this is the Pokemon. All these are actually mapped to the our resolvers. So what do you think about the Pokemons? How it is getting resolved to this Pokemon array? So that is getting defined in this resolver. So this is the Pokemon, and these are the leagues. So leagues means give me all the leagues, Pokemon, and here we are just passing the ID. Okay, give me the league based on this particular ID. Rest all are mutations, create, update, delete. Here also, if you look at the resolver, Pokemon resolver, here also we have all these methods. The Pokemons, create, update, delete, and if you look into the GraphQL, here also we have a create, update, delete, Pokemons and Pokemon. So we have Pokemon and this is the Pokemons. So there is a kind of a mapping we are trying to establish. And another important part is in the Pokemon entity, because there is a one-to-many relationship we have, and here we are doing eager fetch. That means while doing a dot find by ID, you don't need to provide a relations in TypeORM to fetch the foreign key relationship data. It is setting the relations to eager. That means when you do the dot find, it will fetch the foreign key table data also with that. Otherwise you have to do uh, fetch comma relations and pass the relations in that. Okay, so this is all about this. The important part is the mapping of the resolvers with your type definitions, which we are doing here. The mapping of league, and so these mappings should be appropriate. Okay, now the another part is, let's do npm run start, and we are doing TypeORM synchronization true. So what it means is, whenever we are making synchronize true, and when you do npm run start dev, it will always synchronize your entities with the database. So if I look into the database, you can see I do have a league table. This is a simple structure, and I have Pokemon. Pokemon has the foreign key, and it is having the league ID, which is a foreign key. I mean, this league ID is a foreign key from the league table. Here we do have name and ID. So this ID, which is a primary key here, is a foreign key in the Pokemon table. So if you look at the structure, this is the league ID we are passing. Okay, so this is the database relationships. Now we can start this. Let's see how it goes. If your type definitions are correct, then you should be able to start it in one go. Otherwise, let's say you did some typo and all these things, then you have to resolve them. And here you can see it is also keep synchronizing. If you change anything in the entities, this is a TypeORM sync, automatically synchronize. So our tables are ready. Now we can start looking at the GraphQL definitions. I have already imported both the modules here, Pokemon modules and the league module, and now we can say this. So there are different type of GraphQL clients you can use. By default, when you hit this GraphQL, you will see something like this, and here is your schema. You can see the league, these are the queries, these are mutations. Now it has combined all the queries and the mutations together. So this is the schema, these are the queries and mutations. Let's say give me all the leagues, give me a league by ID, give me all the Pokemons, give me a single Pokemon. Mutations, create, update, delete league, create, update, delete Pokemon, and this is the Pokemon type and the deleted custom types. So here we can start writing the queries and mutation, but I'm lazy, I don't want to write the queries and mutation. I can use this client. This will give you a single click execution. So this is Altair client, and you just put this URL, click docs, it will download the docs, and you should start seeing all the queries, mutations. And here let's say I want to create, so this is what mutation. Let's clear this out first, and you go here and click add query. It's simple. Hello, so till now we have seen how this is going to work. We are able to start the NestJS application, and we were able to see the GraphQL spec through the browser. Now next important thing we are going to do is assigning the league ID to the Pokemon. Till now the Pokemon and the league entity both are independent. I mean, there is a relationship, but through the GraphQL queries we are not associating them. So what we are going to do is we are going to create a assign mutation, which will take two IDs. One is the Pokemon ID, another is a league ID. Okay, and we will create a method inside a service. What that service method will do is it will uh, find the Pokemon based on the Pokemon ID, and it will assign the league object to it. So it's like we are going to define the relationship, and this assign method assign the league ID to the Pokemon we are going to expose through the mutation. So to do this, we have to use the repository. We have to import the league repository inside Pokemon service, and for that we can copy this from the league entity here and we'll paste it inside a Pokemon service. Here inside this service we are using two repositories, so we have to do some updates in the module also, because currently TypeORM.4 feature we are doing passing only Pokemon entity, but now we are also using the league entity inside the Pokemon module. So there will be a dependency injection error if we don't import, that we will see. So here what we are doing is we are doing a find operation. First find Pokemon, then find one league, and then Pokemon.league equal to the league. So this is how we are actually updating the existing Pokemon record and assigning the league to that, and then we will return the Pokemon object. So this assign league method we are going to expose through the mutation. So if we are adding a new method, we are adding it in the service, then obviously we have to add the same method inside a resolver, and inside resolver we are going to use the same mechanism, like we have to define the annotations, annotation, mutation, and assign method. So here we can see inside the resolver we'll just copy this method mutation and we will just change it, and here we are going to use assign. It is going to take two arguments, one is the Pokemon ID, another is a league ID, and we don't have type, so we have two arguments. And now we can call the simple service method, which is Pokemon service dot assign league. That is a method we have. So here we are just correcting the arguments, and then we can just call the method. So we need to pass two arguments here, assign league, and we are passing the Pokemon ID and the league ID. Now through the basic queries and mutation we can create Pokemon, create league, and then we can use this assign method to associate the league to a Pokemon, so that we can also see the aggregated data where Pokemon should have the league, and league list, I mean the list of leagues also start populating the Pokemon data. Okay, the another important part we have is the eager fetch. There is a many to one relationship between Pokemon and league, and how to fetch the data, like whenever we do a dot find, automatically it is going to fetch the data because we are doing the eager fetch. And here we can see we are getting this error because we are not passing the another entity for Pokemon module. So what we will do is we'll copy the league entity inside Pokemon module, and we'll pass that inside a TypeORM module .4 feature, so that this league entity is identified in the Pokemon module and our application will be healthy again. So till now we have created this assign method, which is assigning the league to a Pokemon ID, Pokemon record. First we need to create a Pokemon, create a league, and then pass both the IDs in this assign method, and this is how it is going to work. So here we have created the assign method. This is our resolver, and similarly we also have updated the service. So this is creating error. Let's see what it is. Expected colon found bracket. So let's take a look onto the GraphQL file, because this error shows it is something to do with the schema. So I think we forgot to return from the assign method. Now I think when we restart, it should be able to resolve this error. One more important thing in this example is we are doing a two-way relationship, but in the GraphQL files we should do this relationship one way only, like we are specifying the Pokemon in the league entity, league model, and the league model in the Pokemon, right? So it's kind of a cyclic dependency we are creating. When we are fetching Pokemon, we can fetch the leagues. When we are fetching the leagues, we can fetch the Pokemons, but do not make that property required. Okay, let's see, we are starting the server again, and let's see that in the GraphQL spec how we can assign the league to a Pokemon. Here you can see this is the schema file which is getting generated whenever we are starting the application. This file is automatically generated based on whatever the GraphQL files we have written, whatever the type definitions we have created, like the Pokemon, the league, and all the queries, all the mutations. And this is the method, these are the methods which are exposed through the GraphQL playground. And here we can see the latest mutation, which is assign. Assign is taking two IDs, ID and the league ID. And what we can do is, here we are creating a league. We can just put some new name. This is creating a league. We will copy this ID and copy it and put it somewhere so that we can reuse this ID while doing the assignment. Okay, now we can talk about the create Pokemon. We are passing the name, and here we'll create the Pokemon independently through this mutation. We got the ID. Now we can use the assign. Here what we are doing is we are passing the Pokemon ID, and the next ID is the league ID. So both we are copying, and we will trigger this mutation. This will define the relationship. This is what it should do. And this is the error I was talking about, because the league is dependent on Pokemon, Pokemon is dependent on the league. I mean, while defining the types, we should not make these property required. So you can see the Pokemon.league value here, that is required because currently there is no association happened. So inside league, inside the Pokemon type should be optional, so it should not throw any error. Here we are able to assign. Now we can query the league, the list of leagues, and we can see what we are getting. I mean, ideally, if the database IDs are populated correctly, we should be able to see the data, but looks like that is not happening. We are not able to see the Pokemon inside the league objects. It is coming empty array, so we need to check the code, what is happening. Maybe looks like the assign method, whatever the logic it was executing, that didn't process things properly. We can also check the list of Pokemons with the league. Is it populating the leagues with the Pokemon? And here you can see not all Pokemons has a league, and what we have done is we have marked league required inside a Pokemon. So we have to make the league optional in the Pokemon type, Pokemon model type, then it will just work as expected. So now next thing, we need to check the code where it is breaking. There should be some condition which is not correct. Even in the database, we can also check the record if the foreign key is populated correctly or not. First of all, make this optional. So inside Pokemon, league is optional because league ID in the Pokemon is nullable field. Not every Pokemon will have a league assigned. Okay, and we should avoid this cyclic dependency and keep argument optional if we want to do it. Now let's find out where is the error. So if we check the database, inside database we can see this league ID is empty. That means while doing the assignment, things didn't go the right way. We go to the service, and here we will check. Okay, looks like we found the error. This ID should not be the Pokemon ID, it should be the league ID, right? Because we are doing a find on the league entity and then assign that league to the Pokemon record. Now we will restart the application and again try the assign method through the mutation, and this time I think we should be able to assign the league ID to the Pokemon record. We will again try the same mutation assign. We have the league ID and we have the Pokemon ID. We'll pick any random Pokemon ID, and we'll also create one league. We can pick some league from this league ID we already have somewhere saved. We will use it and we'll just pass it. Okay, we'll run the mutation. Now the assignment should work, but I think our application is not started, so wait and watch. Okay, application is started and we can see this has been executed, and now we can also check in the database, and now we see the league ID is populated. Now we can do the query like give me the list of leagues. One of the league records should have the Pokemon inside it. So we will just say give me the list of leagues, and one of the league object should have the Pokemon records inside it. So this will show all the leagues, and you can see the first record, it is showing Pokemon. So this is how we are doing the aggregation. First of all, we are doing the eager fetch from the entities. Second, we are doing the aggregation through these GraphQL queries and mutation. Okay, so this is how it works. Let's catch up in the next video. Thanks everyone. Hi everyone and welcome back. Welcome to my YouTube channel, and I am Tarun, and in this playlist we are already talking about NestJS GraphQL, and we are going to finish this playlist before starting the new one. And it's a long time since I haven't published a new video, but this time my target is to finish up this playlist and talk about something brand new topic like Svelte.js and writing microservices and developing the Uber Eats clone app, which we were developing since last couple of days. I didn't get much time, sorry for that, but now I will be uploading those videos and it will be fun writing all those apps. Okay, so in this video we are going to talk about another example of NestJS, GraphQL and TypeORM, and after that I'm going to cover NestJS, GraphQL and Prisma. I mean, both are equivalent. Prisma is now popular, so people started exploring it. TypeORM is something which is well established stack, and we are already using TypeORM, Mongoose, different other type of query builders. So first finish up this, then we will talk about Prisma. So this is all getting covered under the NestJS GraphQL series, because all are exposing the GraphQL APIs. Either it is now we are using either NestJS or the GraphQL. I'm going to add it into the master playlist, and the link will be in the description. Hi everyone, so if we look into the code, like what all I have covered, the same code is already on the GitHub repository. In first couple of videos we talked about the Pokemon app, in which we were having create Pokemon, update Pokemon, and assigning a league to a Pokemon. This is something which we have covered in the GraphQL. This was the generated GraphQL schema we had. And if you look into the Pokemon, here we have defined the .graphql files, which contains the types, queries and the mutations for Pokemon and for the league. Okay, so this is, you can say, a starter 01. Now we are going to cover 02. So in this 02 folder, currently I have copied whatever we have on the 01, and then we will update the code in 02 folder. And what we are going to do, we are going to do authentication, authorization at GraphQL layer. Like once you are logged in, how we authorize the mutations and queries, all those things we are going to cover. It's like, you can say, one more level down into NestJS GraphQL with TypeORM. And if you want to look into some existing examples which is talking about, okay, two TypeORM entities and how we can expose the queries and mutations, so those examples are already here, and rest all are empty folders which we will fill up while talking about these stack like Mongoose, like Prisma, and here some more example, advanced example with the TypeORM. Okay, let's get started then in the code. Hi everyone, so let's get started with another example using NestJS, GraphQL and TypeORM. This was the first example we covered. I wanted to talk about particular two different approaches. One is the schema first, one is the code first. Okay, when you look into the NestJS GraphQL documentation, you will understand there are two approaches it is providing: code first and the schema first. First we need to understand what are these two approaches and which particular approach this example is following. Okay, so here you can see we are using GraphQL module.for root, we are providing driver Apollo driver, and here we are providing type path .graphql. So if you look into these folders, you can see .graphql, which is having this SDL syntax, GraphQL type definitions in the league and in the Pokemon, right? So it is like a schema you are defining, and based on that it is generating the final schema here, .schema.ts. This is auto generated. But for this, what are we feeding? We are feeding this particular input, we are feeding the type path. So this is a schema first approach. We are not writing the TypeScript annotations and TypeScript types for these GraphQL types. But there is another approach which is code first approach. In the code first approach, we are going to use decorators and TypeScript classes to generate the corresponding GraphQL schema. Here this GraphQL schema we are generating based on these .graphql files, not based on the TypeScript decorators. So this is known as a schema first approach. We are actually using so whenever you see the type path in the GraphQL module.4 root, blindly you can say that this is the schema first approach. You have defined a .graphql files and it will auto generate the definitions in the schema graphql.schema.ts. But when you don't see it, that means we are using TypeScript annotations and types to generate the GraphQL schema.ts. So this example was talking about schema first approach. Okay, in the schema first approach we were using type path and we were creating these we were having this .graphql module for each and every entity modules like Pokemon and Pokemon League. We were having these .graphql files, and finally we are generating the definitions in the GraphQL schema.ts. So what is the major difference here when we start using the code first approach? So code first approach, here we are actually going to use object types, path types, all these different types in our case. So resolvers are still going to be there, obviously the resolvers and services. The only difference here, if I pull in the documentation, that would be more helpful, I guess. So this is the code first approach. In the code first approach, what we are going to do is we are going to use object types. This is what we were doing earlier in the schema first approach. We were defining the types in the .graphql files. Now this particular thing will get converted into the TypeScript classes, because we don't need to switch between the .graphql files and the TypeScript. If we are going to use code first approach, we don't need to write it. We can just write a simple model, like author has a field. So we are going to use object type and field, which is coming from the NestJS GraphQL. Okay, all the typings are there: field, int, boolean, string, object types. So whatever we were defining in the .graphql schema, that will get converted into a ES6 TypeScript class with types and the object types and fields. These are the annotations you have to use to tell, okay, this is representing the author GraphQL type, having these three fields: ID, first name, last name, and the post. Post is of type array of post. Okay, so now finally when the above GraphQL class, above class will get converted into this kind of a type. So this is NestJS will generate it. We are using field, object types and all. So similarly, I mean, you can put more definitions, more information about using these field decorators, like what is the definition, region, descriptions, and what is the type. Here, like let's say the posts is of type post array. So we are using the array annotations. The only difference we are doing here is we have added these fields. Rest, it looks like a simple DTO class. Okay, so this is the approach we are going to adopt in this particular example. Here you can see we have the post as an object type, and it has all these three different fields. So here we are going to write these models, and then we are going to write resolvers. Resolvers, I don't see a major difference in writing a resolver. Either you use a code first or the schema first approach. Resolvers will be using your services to talk and fetch the data. So like this is representing query, it is returning author model. Author we have already defined, like this is the post. Similarly, we have author somewhere. This is the author model. So that query is returning author model that contains all the required attributes. And in the author model, we have to resolve the posts. Post, like when we are getting a author, then we also wanted to return all the posts from the author. So we wanted to resolve a particular field like posts. In that case, we have to pass the author ID. So we are resolving a particular field post. For that we have to use it. So resolver, resolve field, arguments, all these are also annotations. Arguments like this can be a single DTO class or single variables of type int, boolean, string, object, and this is resolving a particular field in from the model. So there are a lot of examples here, like this query returns author. So this will gets indirectly gets converted into this SDL type query. This is of type query and it is returning an author. You can say it is returning an author and taking ID as a integer input which is required. Okay, so this is how it is going to work on. So the query annotations, here you can specify all these inputs, and in the argument decorator, here you can define argument a particular variable or a particular object type. Let's say this is get author, which is taking ID as input. Here it is a create author. I say it like you wanted to specify this particular method is taking 5 arguments. So in that case you can't keep writing okay first name last name. Instead of that, you can create a get author argument. This is the class argument type, can have a multiple fields inside it. Okay, so this is the argument type and all these fields are inside it. So these are the annotations, and once we start using these looks like DTO model classes, but with the object types and the field types are already defined. And when it comes to passing an argument in the simple NestJS services, we are using DTOs and we are applying pipes and DTOs. Here also it is the same. We are just creating a class and putting the argument type annotations, and for the attributes we are using field. Okay, so in this example we are going to use code first approach. That means we are not going to write. So here we are going to use code first approach. That means we are not going to write a .graphql files. The type path we are not going to provide. We are going to use object types, fields, and these typings. And this is how we are going to create a classes. And we'll use these annotations to automatically generate the schema file. Okay, let's get started for that. Hi everyone and welcome back. Welcome to the second video, and in this video we are talking about NestJS GraphQL. So in the last video we talked about two different approaches, schema first and the code first approach. In the schema first we are writing the types, we are using the GraphQL SDL language, and in the type first, so there is a schema first, there is a code first. In the schema first we are writing typings. In the code first we are not focused on the GraphQL SDL language where we define type query, type mutations, and create custom types. Here we are going to focus more on the annotations, more on the types we are going to create through the TypeScript classes. We are going to use this object type annotations, field, and different custom types which has been added in the NestJS GraphQL TypeScript module. So only major difference is here we are not going to hear anything about schema, anything about GraphQL SDL types. We are going to do everything in the TypeScript classes. Okay, what I did is I recorded 2 hours video. Somehow the file is corrupted. I did the live coding of the whole project, but what I'm going to do now is I'm going to walk you through the code. It's not that complex, it's very simple because I have already covered many videos on NestJS TypeORM with the Postgres. It's kind of same setup. Here we are going to have 3 different modules. This is the domain module, and inside domain I have a category, employee, and project to show the relationship between different entities like projects. Your organization project, you have employees, you have different categories for the employees. So there will be a one-to-one, one-to-many, many-to-one relationship in the entities, and we are going to expose query and mutations from all these 3 modules. Okay, so inside domain module what do we have? TypeORM module, NestJS GraphQL module, and the config module. Same as the last video. So we have config module, TypeORM module, and GraphQL module. TypeORM module takes the same thing. It takes the URL, type, name. We are not passing the 10 different argument. You can just pass the URL, and synchronize is true. That means whenever the NestJS application starts, it will synchronize the entities with the database. Type is Postgres, logging is true. Logging means you wanted to see what all queries. TypeORM is executing when you are hitting the queries and mutations. Synchronize true, it will always sync the database with the entities. GraphQL module, here we just need to pass the definitions. Okay, when I'm looking into, when the GraphQL will look into all the DTOs and all the types, what should be the output? Because output we have to generate, either you use schema first or the code first, and we are going to generate the output in the root folder. That will be graphql.schema.ts TypeScript file with all the types. Okay, so what is the next thing? I have already created all these folders and setup, but it's category. You define all these services. So what a module contains: a module, a service. We don't have a controller because we are writing GraphQL. We have a resolver instead of controller. So we have service, we have resolver, we have module, we have entities, and we have DTOs. Rest all the things are same. What did we do is, we now don't have a controllers, because controllers are router and those are used for REST APIs. Here we are writing GraphQL. So GraphQL needs resolvers which can be exposed through which will you consume the services, and you will pass the resolver in the main module. So if I talk about a simple employee module, what it contains, we are already using TypeORM module. You pass the entity, because I'm going to use only employee entity here. So I have employee resolver, employee service, right? And you can see employee resolver, employee service. I have DTOs and I have entity. So these are TypeORM entities. Now there are big differences here. Like you write a simple NestJS TypeORM Postgres app. Here inside entities we have to define the typings. So what types you see? If you remove the object types and the field, it is same as the plain old entities we were writing for TypeORM, with the different annotations like column, unique, generated column, primary generated column, and then one-to-one, one-to-many, many-to-many annotations, and then entity. These are what the existing code we were writing. Now what we have added, two things: object type, field, and types. Because somewhere if you wanted to use int, boolean, these are GraphQL types which you have to map with your columns in the database table. Okay, this is the field, I got it. This is a number, this is the string, this is the string. You don't need to specify anything about string, but if you want some column to be nullable or some field in the GraphQL types which is going to be generated as optional, pass nullable true. And then this is employee. Let's talk about project first. Inside project we have entity, project entity, and here we do have only couple of things: ID, name, code, and project has a one-to-many relationship with the employee. That means one project can have multiple employees with it, or you can say one employee can be tagged with many projects. So it's a one-to-many, and it is like single project will have. So employee.project, if you go to employee and look into the entity project, so project is pointing to where it is, yeah, project. So many to one, many projects can be tagged to a single employee. So it's like one to many from employee to project. So you have to define these annotations by direction in both the entities. Here I'm using one to many, and here inside employee I'm using many to one. That means many employee can be tagged to a single project. So coming to the project entity, project has this relationship, then employee, and then employee also has a further relationship with the category, that a single employee can be tagged with a different category. So it's one to many. So one is employee, one is employee, and many is category. Okay, so one to one, one to many, many to one. These are the three different relationships we have created inside categories. If we see the entity here, we have defined many to one. That means many categories will be tagged many to one. That means many categories is tagged with a single employee. Okay, these are the different entities we have and their relationships. Now what we are going to do is, if you look into domain module here, in future we are going to create these three modules also, and then we will put those three modules here: project module, employee module, category module. Okay, So if you already know TypeORM, how to define the relationships and entities, that is very easy. Now I will talk about very simple example is how to create a project. For those, we were also creating DTOs, same thing. We are now also going to create DTOs, create project and update project. So create project DTO, it's everything is same. You can use annotations and all. Here I need to bind things with the type or NestJS GraphQL type. So I will be passing input type. This is one single field. This is another field of type integer, because this will be a body for the GraphQL post request which you are going to submit, right? So field update project, here you might be just passing the ID of the project and the code or the name. So DTOs are still simple, same. You can also add annotations saying okay, this is required or not, using class validator and class transformer, that ID should be of number, name should be of string required, code should be of type number and required. I kept that optional. So now this is like partial type, means you can pass the partial object from this. This is how you can generate update DTO from the create DTO. Now we just directly go to the service and the resolver. First let's talk about resolver, because resolver is the replacement of your controller. In the controller we were using annotation get, put, post and doing a lot of things. Instead of controller we now have a resolver. So it is resolving the type project, because the project resolver is going to return the type project. Okay, so you can see here mutation. So there are a lot of things, queries and mutations. Let's say talk about query first, that is easy. So here inside this query, what I'm saying is I have a project, find one project. So it is saying is okay, find me one project. So what I'm doing is here I'm using the arguments ID integer, and then I'm calling the service because we have injected the service here inside a constructor. So here rest all is a CRUD operations like find all project, remove project, find one project, update project and create project. Now the most important part is how we are taking the input. In the controllers we used to do the DTOs. Here also it's a DTO, but the type is different, right? We are using the object types and we are using field for the properties. If you see this create project input, it's of type create project input that contains the DTO, and here we are using input type and field. When there is an input, you have to use input type. When there is an object, create the object type, use the object type. So here we have a create project, update project, find one, find all, remove project. Simple. Similarly, if you look into the employee, there we have a resolver, there we have service and entity and the DTOs. Let's say like create employee, update employee. Simple couple of fields with the input type, update employee. And when we wanted to create, so this is the employee entity. Employee has a relationship with the category and the project, many to one and one to many. This is the employee service, which is using the TypeORM repository, same as the project repository. Here we are injecting the TypeORM employee repository, and we are using this .employee repository.create and then save .find all, and here we need to populate the relationships, because in the GraphQL queries we wanted to also fetch the data, because we don't want the lazy fetch, we want a eager fetch. So wherever you are doing find all, find one, always populate, always try to get the relations. So employee has a relationship with the categories, so employee repository.find. Here we don't have any where clause. I wanted to fetch everything, so I'm just passing the relations. Otherwise you can also set where clause and pass your ID is something like this, but we don't have ID, we wanted to fetch all. Here find one, so employee repository.find one, here we just wanted to find one. If you wanted to populate the relations, then you can also put find one employee, and then populate the relationship or relations also, which is categories. Similarly, update, first find one based on the ID and then update the properties and save it, then delete. So this is the employee service that will be consumed by employee resolver, which is nothing but a controller for GraphQL service. So here we have a resolver, it should be returning a type employee, and we have injected the employee service. And now you can call these methods, okay, service employee service dot create dot find all dot find one dot update dot delete dot remove. Here we took the input. These are like aliases we have created. Mutation, what is the mutation name is create employee. Whenever you hit create employee mutation, it is going to call this create employee method. It will take the create employee input which contains the employee name and all, and then you are calling create on the service. Similarly, this is the query which is returning the array of employees. So this is the difference. It is returning employee object, array of employees, single employee object. So here you need to specify so that the types can be generated by looking into the resolvers. This mutation, remove employee, is returning the removed employee. This is updated employee. This is the query. This is returning a single employee object. This is returning the array of employee objects, because this is a find all. Okay, so similarly we have a category. So this is overall, I just want to walk you through the code because there is nothing complex here. If you look into the update, we are doing update by id, update by employee id. Here we are passing id and the input. So first we are trying to find, give me the employee with this id, and then update it so we can directly save it. Okay, this is just basically TypeORM. I quickly build it. So we have a resolver, we have a services, we have entities and the DTOs for all these three modules. Rest all, we just need to run this project and we need to just play with the data. Hi everyone, so let's start the application. This is our database URL. I already have every other files to bootstrap the database. You just need to do docker compose up, and as we already know, it will create the database. And we already have TypeORM module that will connect to the database, and we have provided TypeORM module.sync true, so whenever you start this, it will create the entities. So what is happening is, let's see the database. This is our database which has a project, employees and category table. You can use any Postgres client and just see what is there in your database. Here we have employee ID, this is the employee table, and this is the project table. Okay, now we can start playing with the GraphQL APIs. This is our Node.js. I just did npm run start and it starts working. This is the NestJS GraphQL with the Postgres TypeORM setup, and there is no API routes because this is a GraphQL, and we can use this GraphQL client, LTR client, that is really nice. You can just send the request and you will get the documents. Document contains like what all queries and mutations this GraphQL server is exposing. So these are the queries: find all employee, find one project. So these all queries we have: find all employees, one project. And if we just check the mutations, these all are the mutations. Okay, like these are like CRUD operations. And here we can run a query or a mutations like find all employees, add query. Here I can trigger this query, and let's see, we don't have a relationship data for now. I just wanted to fetch this information. Find all employees are returning empty. That means our GraphQL query is working. We just need to populate some data through the mutations. Like I can do a create employee and create employee add query, and create employee is taking some argument, I think. And here I can just target this much data for now. So first name is 111. Let's say is everything is string. It is running mutation. Okay, that's good. We created an employee, and then I can hit the query again. And this is a really nice client because everything you get handy. You don't need to worry about writing the queries and mutation. And you are getting the data, right? This is what I wanted to show you. We can talk about all the other APIs like create employee, create projects, create category, assign category, and tag the employee with the projects. All these things are there, right? But this is just a simple demo. What I wanted to show, every setup is there. We have Docker Compose up. So this is the TypeORM sync. If you delete the tables, let's say if I delete the tables or delete the database, or let's say delete the container, you can also give it a try. I need to remove the volume also, and you purge the volume so the data will be gone once the container is gone. So we have removed all the volumes. I will do Docker Compose up to spin up the container again, and then I will do npm run start so that we can see everything comes up again. Here I will do Docker Compose up, so it should spin up the container. Then we just need to restart the application, and now we have a database up, but we don't have a tables. TypeORM sync will create those tables for us in the database, and it should start working as it was. Now I can just kill the application, and I will start the application again after I create the database. So here we can see our database is created. Npm run start has also started the application, and we can see that now in the database, because database is also again populated with the same table, and I think now data is empty, so it will show something like this. We can again trigger the create employees and see how it is working, but this is how it is overall looks like, right? We are doing the NestJS GraphQL code first approach, where we are using these TypeScript annotations, object type, input type, field, and all these annotations, and we are making our task easier. Okay, so that's it for this example. What we will do is in the next example we can talk about Mongoose. The only difference is let's replace the TypeORM with the Mongoose, and we can use the same set of approaches, schema first and the code first. We can talk about the code first with the Mongoose. We can have just a single model, and we will just do the CRUD operation there. Okay, thanks everyone. Hi everyone, and welcome back. Welcome to another video, and in this video we are going to talk about NestJS GraphQL code first approach with MongoDB. So in the last video we talked about code first approach with TypeORM and Postgres. This time we changed it to NoSQL, and we will see what is the difference. It's just like we are just changing the persistence layer from Postgres to MongoDB, and we are going to use Mongoose. So it is a plain and simple example, so I want to walk you through, not like writing the code, because it's not it's not much code we are writing. Here instead of TypeORM module.4 root async, we are using Mongoose module.4 root, and you can pass your database URL. And I already have a docker compose.yml. You can just do docker compose up, your MongoDB container is up and running, and you can start consuming the data. So I just have items module, which I have added in the app module. This is the items module. Items module has a service, resolver, and DTOs, and the schema, because we are using Mongoose. So in Mongoose we define a schema, which is a representation of a NoSQL table. And here we have items module, which contains Mongoose module.4 feature, what is the schema name, what is the model name, the representation of model object, which is an instance of the model, and the schema. This is the item schema, and the service and the resolver. Same, we are going to replace the controller with the resolver, and the service which is going to access this MongoDB model. Here we are using inject model items, and so that we can do item.find, item.save, item.find1, find by ID and update, find by ID and remove, all these different possible basic operations. So I will not go into much into the deep, because this is just a simple item CRUD. Here I'm doing create. For this create, I'm taking item input. First let's talk about resolver, because resolver is taking the input. Okay, and here we are defining the types, same as the DTO. So here in the DTO I'm using the object type, field, int, input type, all these values I'm using. You can see here I'm doing the field which is of type ID, which is the object ID, and these are others are type string. And you can also add a class validators and all from the is string, is not empty, is defined, is not null, and all these things. So resolver is returning a type of item type. So what is item type? Create item DTO. This is the item type because all these methods are going to return the item type containing the ID, what are the different price, title, description, and all. So this is our resolver. This resolver has all these methods. I'm just injecting the service, and then we have this query which is returning item type array, query which returns a string, query which returns item type, query which returns item type object. These are like update, delete, and create, right? In create, I'm taking the item input and I'm doing service.create, service.update, service.delete, and service.find all. A very simple operations, right? Which is like simple CRUD. And then inside the service we have defined all these methods, because in service we have injected the item model, the mongoose model, and we are doing find all, find one, find by ID and remove, find by ID and delete, basic mongoose CRUD operations. So I will not talk much here because these are very basic things we are talking, and this is how simple it is. Now instead of this, you can have a number of models, write their resolvers, write their services, different modules, and put those modules in the app module. Because my target is to cover more on the Prisma side, Prisma, NestJS, GraphQL. So I just wanted to talk simple examples for the mongoose. So we can run this. I will do docker compose up and then npm run start, and we should be able to access the queries and mutations exposed by this GraphQL setup. Okay, now we can see a demo like how it is working. This is our docker compose file, and I did docker compose up, and it was able to spin the MongoDB container, and then I did npm install, npm run start. That's it. Okay, and it is starting this NestJS GraphQL server with mongoose initialized, item module dependency initialized, and then we can just reload this so we can get the updated documents. And here we are, we can see we have these queries and we have the mutations. So let's try this query. And this is returning empty, and then we can create the item. This is a mutation, and I can run the mutation, and then I can again hit the query, give me all the items. So this is like plain and simple how we are executing it, right? So this is simple example of NestJS GraphQL with a mongoose and MongoDB. And you can just add on to further modules. Instead of item modules, you can have a user module, comment module, post module, and define the relationship with the MongoDB collections using references, and you can build the whatever the APIs you want. Okay, so in the coming videos we will talk about NestJS GraphQL with the Prisma. That is our main target and main focus, and I will cover at least 1 or 2 applications with that demo examples and how it is working. So stay tuned and let's connect in the next video. Hi everyone and welcome back. Welcome to my playlist. I'm covering NestJS GraphQL with all different ORMs. Like we have already covered NestJS GraphQL with the mongoose, with the TypeORM, Postgres. This video is for NestJS GraphQL Prisma app. And first we are going to talk about NestJS GraphQL Prisma app schema first approach, because there are 2 approaches, schema first and the code first approach. So first we are going to talk about schema first approach. So I have already created a separate playlist. If you are beginner, if you are not aware what is Prisma, how it works, how it is different from TypeORM or any other ORM, then you can take a look. Otherwise just get started if you're already aware. So what I already have is the docker compose file and all the required files I have to spin up the container. So what do you see on the screen is the docker compose and compose override file, and I'm using the same setup of Docker containers in each and every video. This is Docker compose file, and then there is a override file, and when I do Docker compose up, it should be able to spin up the Postgres container for me with example API database. If I just check, because we are going to use Postgres for this, I will just remove this database which we already have, and then we can create the container again. That is the first thing, because here we are going to talk about Prisma. Prisma will use some kind of a data source, either a Postgres, MongoDB, MySQL or something else. So let's create first Prisma folder on our root workspace. The default code is just a Nest CLI generated code, and here we have to create a schema file. That is the first thing we have to do. Schema.prisma file, and here we start defining, okay, what is our data source and all these things. And I already have a plugin, it should help me in writing this file, data source db. So provider is PostgreSQL, and URL will be, I will be getting this from environment. So whatever, because when you do Prisma generate, Prisma migrate, it will look into .env, look for database URL, and will load that variable in the process.env and will start using it. Okay, then we will just specify generator client. I think now it should start supporting autocomplete. Generator client, and we have to specify provider here. Provider is a Prisma client.js. You're already familiar that Prisma will generate a client for us, and here we can start specifying the models. Let's say model post. Here ID is of type int, title is of type string. We have written a lot of models like this. Content is of type string, published, it has specific language, we have to follow that. At the default is false. Same is created at, this is of date time type, and the default value will be now whatever is the current date timestamp is the default value. Okay, so what we did is we created a basic schema. Now why it is complaining, provider URL PostgreSQL, provider is a PostgreSQL. Okay, I put the comma, that was the mistake. Created at datetime, and default is now, that is a function, and now it is complaining. Let's see what is that. Content, and okay, for ID we have to add auto increment. I'm working with different framework and it's easy to forget these kind of syntax, so you can take the reference. It should be auto increment. Now it is fine. So we have just a simple demoable Prisma schema created. We have Docker compose up already running, Docker container, and then we can just start executing some commands to migrate. I mean, we have to generate the migration, then execute the migration against the database. So we don't need to generate because we are already writing the schema inside a Prisma schema.prisma file, which is inside a Prisma folder. Then we need to have this one npm script to run the migration. So what I will do is npm run migrate. It will look into schema.prisma file. It will check the PostgreSQL, load the database URL, and create this table. It will first create the client if you do the Prisma generate in your node modules, Prisma client, when you do Prisma migrate, it will create this table if doesn't exist. I mean, if the no existing migration exists for post which has been executed, otherwise it will create a new one. So we can do is npm run migrate. So what this is going to do is Prisma migrate dev. It will just load the environment variable from .env file. It will see, okay, data sources example API. It will connect to the database, and we already have the database URL in the .env file. That is important part, don't miss this. You have to populate the database URL, the exact database URL with the username, password, host, port, and the database name. Okay, you can enter the name of the migration, otherwise it will take the default one. Okay, so you can see migration has been generated. This is the migration file. This is just creating the post table, right? Now you can add couple of more tables, couple of more migration models, like, okay, user, whatever you want to do, user model. So what you can do, you can create a user schema for that. So let's create a couple of more. Let's say I'm going to create a user schema. Okay, so what it will be, simply model user. Okay, and here you can actually use couple of these attributes, copy it as it is. I think the attributes we are going to change: ID, it can be email, which is of type string, name string, then we have password. Okay, so email, we want to have this is a unique, name is a string, password is a string, and then you can also have different references, like, because it's a RDBMS relational database where you have to specify one-to-one, one-to-many, many-to-many kind of relationship. I'm just keeping it like simple. We have the user. Similarly, we can have post. We already have post. We can also have a category schema, like what will be the category of a particular post created by user. And then you can also model the relationship in all these. So ID, it can be simply name of the category. ID, name, description, and allow this for the execution. We will execute the same command, npm run migrate. It will just check, okay, user and category, something new has been added. So I will run the migration, and I will just create these tables against the same database. And you can also do npm run generate command. Generate command should actually generate the client for us, same as the migrate. So migrate is actually migrating the tables, migrating the schema to the actual database, and generate is creating the Prisma client, because we keep changing the code and we have to generate the client again and again. So let's say if we execute Prisma generate command here, so this is my package JSON, and I will just add one more command. So it is calling Prisma generate command, loading environment variables, and it should Prisma schema loaded into Prisma schema, and then it should create the updated client in the node modules. So this is the Prisma and this is the client, and here you can see all the models created. So what all model we have: model post, model user, and then model category. Everything is updated. So when you go into the node modules .prisma and the client, if you see everything works fine, that means your client is updated. And then now you can start using the Prisma objects like this, like prisma.user, prisma.category, prisma.post, something like that, because the client is available and you can start consuming this. Okay, let's see that in the next video. Okay, so now what we can do is we can create the Prisma service, we can create the post module and all these things. So this is our source folder, totally empty with just a basic structure. Here what we are going to do, we are going to create a Prisma service which will do the Prisma, which will connect to the database, which will just talk to the Prisma client and will tell us if we are good with the connection or not. Prisma.service.ts. So here we are going to use the Prisma client. So import Prisma client from Prisma client, and we are going to import it from Prisma client. Okay, and then we can just create an injectable service, and this service will initialize the connection. Export class. Okay, we have to import all these things. Export class Prisma service which is extending Prisma client. Okay, and this is implementing the on module init so that we can use on init method and do the connection check. Implements on module init. Okay, this is an interface, so we have to define the method. So we can just use on module init. Inside this method we can do this dot $connect. This method will make sure that we are connected or not, and that is just a shutdown hook, like whenever you are destroying the application, then before exit the application should get closed. That is just for clearing the resources. So it is taking app argument, app which is the NestJS application. And what it is doing is it is just checking for this particular event, this dot $on. So we are looking for before exit event. Before exit, do this to close the application. Okay, we need to import a couple of things from NestJS common. On module init, this should also comes from NestJS common. Okay, this is how it is looking on module init. I don't know why it is complaining. Does not have exported member on module init. Okay, I think O is in the uppercase. Okay, so this is a Prisma service. We have to use this Prisma service in the app module. Now we can start talking about our posts. So this is the post module we are going to do. Inside the post we will create the resolver, the service, post model, post.module.ts. We also have to specify the schema and then pass all these schema path in the GraphQL module.forRoot method. So here it will be schema.graphql. Okay, let's first define the schema, what all query mutations we are going to write, and the same we have to populate in the resolvers and service. So service will just do the Prisma CRUD operation. Then we have resolver. Resolver will define all the queries and mutation. I mean how to act on the queries and mutation. So we have ID, required. This is the title, which is of type string. Content, again type of string and required. Published, of type boolean, and created at type string. Okay, so now we can also create some input types, some custom types which we can use to pass in the resolver. Like I wanted to create a new post, what all things you needed? I need title, which is of type string, required, and content of type string, required. Then we have update post. So update post is again another input type we can create, and then we can create type query, type mutation. Inside type query, I wanted to fetch all the posts created. So what it is going to return? All the post. Its post should be an array, and it is taking, okay, give me a particular post. So that is post by ID. So this is ID of type ID, that is required, and it is returning a single post. Okay, mutation, we have a couple of methods. Create post, it is going to take the input type new post. We can use these custom types we have created. Input type new post, and it is going to return a post, and then we have update post, and it is going to take this input, this custom type updated post, and it is also going to return a single post. And then delete post, which is taking ID of type ID, and it is going to return a single post. So these are the queries and mutation in the GraphQL schema language. I can format this later. Okay, now we need to write resolver and the service. Okay, we can create now Prisma service and Prisma resolver. Prisma service is simple, it is just injectable class. So we already have Prisma service created. Now we can start adding the methods. Let's say async post. So this can be used for getting the post by ID. Either it will return promise of single post or null. Okay, and what we will do is we can just use this Prisma service, this dot Prisma dot. Now you can see all the entities are there. Dot find one unique based on your selection criteria. Okay, here we have where query, the ID is number ID. Okay, if this is there, otherwise it will return null, and you can import all the other required things. Import post from this injectable, we can import from the NestJS common post. Now what all other methods we can think of? Okay, give me all the post, get multiple post. So we'll just use copy and paste. Let's say there are 3 methods we have. Async posts, give me all the posts. It will not take any argument, it is going to return the array of all the posts, and we are going to fire find many method on the Prisma client, Prisma model, find many without any where clause. This should be able to return us all the posts. Then we have create post. Okay, now for create post we have input, and then new post. This is the typing we have, but new post is not an interface we have created. So how we are going to get the typings for these custom types you have created, new post, updated post, right? How we are going to do this? So there is another way of doing it. You can generate the TypeScript typings from your schema file. So for that, I think we already have this generate typings.ts. It's just using GraphQL definition factory and it is doing calling generate. You need to pass the .graphql files and it will give you the graphql.ts. So you can execute this command node, or you can also execute npm run typings. I think I added something in the package.json. You can execute this ts file using ts node. So if I do this, if I do this, what it will do is it will generate the schema.ts file. So if you generate typings.ts, it will generate graphql.ts file which contains all the typings. So if you look into src, we have something like this, and it has all the types: export class new post, updated post. I mean, it's not recommended. I mean, it's recommended, but you can also write DTOs to manage that. So here inside post resolver, I can use the generated Prisma typings. So for that, is it not exported? Exported new post, export class new post, and we can use this here for the input. And then we are passing id. Id is okay. We are going to change this. This is a create post. Create post is taking this payload. This prisma.post dot create is the method, and you can simply pass data as input. This will do the creation. And then if you talk about update post, so instead of input new post, there will be update post. And then what we will do is this prisma.post.update is the command I will execute. And inside update, whom you are going to update. So you need an ID for that. So first I will get all the attributes outside this payload. So we have input, and we already know what all attribute this blog post contains. So we have ID, title, content, published, and this is update post. We need to get these typings correct, and then here update where ID is this and the data is this, because it takes two arguments: the where clause where you can specify the ID, and here you have to pass the object. So there is a shortcut, like, because this is you are not going to update all the attributes together. Let's say I am passing published. If I am passing it, then return the published object, otherwise do not include it. So instead of writing the if else kind of stuff, this is the quick and nice way of managing things. So if published is there, if title is there, pass the title as a property. If content is there, pass the content as a property, and it should be able to update. Then the last we have is delete post. It's kind of simple. Delete post is just calling delete method prisma.model.delete, and it will delete it. Okay, I need to get these typing straight. src GraphQL, and then I have update post. I can just directly update the import definition. So this is the post service. Now my resolver is going to use this service to create post, list post, update post, and delete post. So our next thing is resolver. We put this code in different file. This should be in the service, and this is my resolver, and I will just name this as a post resolver. Okay, and here I'm going to use this post service which we have created instead of using Prisma service. I just copied the service into the resolver, so we don't need to write much code. Here I have post service. Now here I need to use the query and mutations and all these methods instead of all this method, because I'm going to call this post service from post resolver. So let's see how it look like, and then we will just quickly jump to the demo. So here we have constructor, we injected the post service there, we imported it, and now let's say our simple one is the query. Give me all the posts. Okay, and this is async posts, and here I'm going to call return this dot post service. Let's call it as a post service. This dot post service dot posts. It will return you all the posts, and that is what you needed. Similarly, we have other query like get post by ID. So we can just add another one. Then we have 3 mutations. So this is the query for the single post, async post, and here we are passing a single argument. So argument, this is ID, and this argument is of type string. So this is a single argument, and you can just pass that here argument. Okay, let's fix this. What are these warnings and errors? So argument is coming from NestJS GraphQL. It's ARGS. And then query. It should not complain now. Okay, we have, let's see this. Route handler parameter decorator exactly the query. Find. Okay, sorry, this should be a resolver, and this is getting this is resolving the post, and then we can import it from NestJS GraphQL. Okay, this query we mistakenly imported from somewhere else. It should come from NestJS GraphQL, and now we see things correct. Similarly, we have mutations. I will directly write them down. Mutations: create post, update post, delete post. Right, and just import the mutations, and I will fix this thing. Okay, now our resolver and the service is ready. Now we need to plug it into a module, and we need to pass that module into the app module. That's it. We are ready. We can just check how it is working. So this is our app module. We imported the post module there, and we are just using GraphQL module here, .4root, and Prisma module. We are not directly using something like Prisma module .4root or nothing like that, because we have generated the Prisma client, and we just have a Prisma service which is just checking the connection to the database and releasing the resources once we destroy the application. Okay, so here we have post module which has everything. I started the application. We already have Docker Compose up running. We already created a Prisma generate, Prisma migrate. We have already done that. Now we can just look into the documentation, like what all GraphQL APIs we are getting. This is just a simple CRUD create post, and then we have some mutations is like create post, update post, delete post. Now we can play with this. We are just running a mutation, and then I can just simply do a query. Give me all the posts. Remove mutations and trigger the query, and you get the data, right? So this is just a simple example, simple and stupid, nothing much, nothing complex, just to refresh our concepts of how we were dealing with the Prisma, like how we were doing a Prisma generate, Prisma migrate, and then writing Prisma surveys, and then writing the different modules which were using the Prisma clients to read, write and update data. Here we were using just post service and post resolver. Post resolver is calling post service. Post service is using Prisma client to do all different operations on this entity. Okay, so this is pretty much. Now we are going to talk about little more complex example of NestJS GraphQL with the Prisma, which has authentication, authorizations and multiple entities and a lot of relationship between them. Okay, so stay tuned. I will post that as a next video. Hi everyone, welcome back. Welcome to my another brand new playlist. And this playlist is not like separate playlist. We are already talking about GraphQL. In my previous videos, we covered Apollo GraphQL, we covered Yoga GraphQL with Express. Now it's time to talk about these things with NestJS. So I'm going to add all these videos to the GraphQL master playlist. Okay, I will add that in the description. But like if you are already aware about how GraphQL works, how it works with Express, and you wanted to explore how it is going to work with NestJS, because on my channel I have a lot of content on the NestJS, but all are talking about okay how to build a microservices and all. But what about if I want to build a service which exposes the GraphQL interface instead of REST interface, right? So those things we are going to talk in this playlist. So our focus in this playlist will be on different aspects. First of all, NestJS GraphQL setup, okay, how to actually build the service from the baseline. Then how we can work with the different database like Mongoose with the MongoDB, TypeORM with MySQL, Postgres, and then Prisma with any of the SQL or NoSQL database. That is the main agenda, and we are going to talk about multiple examples. Okay, the main focus is how GraphQL query mutations and subscription can be exposed through NestJS service. Now changing the database, changing the ORM layer is just a simple topic which we can